All right. Now we up to now we already covered 3 chapters. Chapter 1, chemical bonding. Chapter 2, gases. Chapter 3, intermolecular forces. Today we look into chapter 4, solution. Chapter 4, solution basically will be about 70% of your final exam, which is the skill that you learn in this chapter is applicable in your lab report, applicable in your final exam, and also your test 1 and so test 2. Okay. Now chapter 4 will focus a lot of equation, right? In balancing the equation, yeah. Okay. Chapter 4, we learn about what is homogeneous mixture. We learn about concentration, which is molar, how many mole of solution. Then we learn about dilute, how we dilute from 1 mole into 0.1 mole into 0.01 mole, and so on. Because you need to know how to dilute in your experiment. We give you one concentrated solution. You dilute into 0.1. I give you 1 mole. You dilute into 1 mole solution. Then you mix with the 0.1 mole solution and you observe the changes. Okay. And to revisit stoichiometric solution means you need to balance the equation. Right? Okay. So let's go into chapter 4. We try to finish until concentration if we can. If not, we must finish homogeneous mixture by end of this lecture. Yeah? Okay. So these are the things that we're going to look through. So there's one incident in Cameroon, which is in Africa. Cameroon, this area, there will be there's an accident that die a lot of people because of CO2. Right? In CO2, you have heard of Nile Lake, Lake Nile. It killed 1,700 people and 3,000 of cattle because of these CO2 gases. Basically, it wiped up the whole village. Why? Right? So we need this incident remind us how important about concentration, solution, and so on. Right? And also answer element that is non-reactive suddenly become reactive. Under what kind of condition, right? So the incident happened, it killed the whole village, it because the lake water, right? The lake water, the village, the water sources is under a volcano. Oh, you know the volcano have lots of high pressure. So the CO2 mixed with the lake water, it formed toxic water. And the village drink the water without knowing it, and it killed the whole village, including the cattle. Right? Because of the concentration. Now in this chapter, we look at concentration. Under what condition? Concentration can bring harm to human life. Right? Okay. So this is the thing. So this is the nature. Sometimes you explain why some people can get killed because of you do not have the knowledge in chemistry. Right? So the village was up because it was built near a volcano. So under volcano, there's a high pressure hot gases shooting in, and then the CO2 mixed with this water and the vapor pour down into the village. So the vapor moved down from downhill. Because of the change of temperature, it cooled down, condensed, and so on. It somehow killed the living life there. Okay. So at the bottom of the lake, it is a solution. And a homogeneous mixture of two substance. So this is to tell you what is the definition of solution. Solution is a homogeneous mixture of two or more substances. You need to add two or more elements to form a solution. Okay. For example, ocean water is a solution of gas and solid that dissolve in the water. Your blood also have there's also a solution mixture of plasma, cord, and red blood, and 55% form of plasma, and inside plasma have all these elements. 1% of cord have all these elements. Red blood cell have all these elements, right? All right, now you will see all these technical words, solution phrases. Solution phrases means the state, either gas, liquid, solid. Right? Solute, later we look at what is solute, what is solvent, and then example, right? Okay. Okay. Now, if you mix a solid to a liquid, the solid normally is called solute. Liquid or things that can dissolve things is called solvent. Solute plus solvent, you get solution. So in chapter 4 question, you need to identify which element is a solute, which element is a solvent, and then you need to give the answer for solution. What is the end results, right? Majority is called solvent. Majority is called solvent. Minority is called solute. So these are the two, solvent and solute. Okay. In CO2 and water solution, CO2 is a solute, water is a solvent. By the component, right? By the component. Salt water solution, salt is a solute, water is a solvent. So this one, this table start to give you, if it's a gaseous solution, both solute and solvent is gas form. Liquid solution, it can be three combination, gas, liquid, and solid combination. Solid solution is only in both solid and solid. Okay, so solid solution, it can be solute in solid, solvent in solid. Right? So the definition of solute and solvent is basically look at the majority component or minority component. Okay. Now we start to look at polar and non-polar. We already finished chapter 3 and we introduce you what is polar, what is non-polar. So basically, polar and non-polar cannot mix. Right? Only polar can mix. Okay. So polar solvent dissolve in polar solute. Polar can only mix with solute, polar. Okay. Solvent dissolve. Solvent will dissolve solute. Solute cannot dissolve solvent. Don't mix the sequence. Okay. And non-polar solvent dissolve in non-polar solute. So polar to polar, non-polar to non-polar. Non-polar solvent dissolve in non-polar solute. So for example, the one on the left column, all these polar can dissolve each other. Water can dissolve in acetone, can be absorbed in alcohol. Non-polar solvent can dissolve each other. Hexane can be in toluene, hexane can be diethyl, for example, right? Okay, so don't confuse chapter 3 content and chapter 4 content. Huh? So this is a tendency. We use a tendency with the rule light, dissolve light. So they will dissolve similar one. Similar kind, dissolve similar kind of solute. So just a quick quiz. Which compound would you expect to be least soluble in water? So this one you need to guess lah, based on your chemistry knowledge, right? So first you need to decide whether they are polar or non-polar. So intermolecular forces, there are 4 types, right? So you know that water is polar, right? So polar can mix with polar. Non-polar can only mix with non-polar. Okay, I ask you soluble in water. So start from chapter 3, we already assume you know water is polar, right? So you need to know whether it is a polar hydrogen bond or ionic or covalent nature, right? ClCl4, if you refer to chapter 1 or chapter 2 table, you draw the periodic, you draw the Levi structures. You know that this is a non-polar covalent molecule. Why covalent? Because there's no metal there. Okay, no metal in the periodic table. C and Cl, non-metal, form covalent. So these are the standard. This will be in your test and final exam. Okay, expected answer, you need to tell me what type of molecule, either polar, non-polar. Then polarity, whether they are polar or non-polar. You need to build the structures and then tell me, refer to the table, tell me what is the geometry of the shape. Does it have hydrogen bonding or not? So CCl4 don't have hydrogen. Straight away, don't have hydrogen bonding. Hydrogen bonding, there are 2 steps. Check whether got hydrogen, check whether got FON or not. 2 steps for hydrogen bonding. Solubility in water, you base on polarity. Solubility in water, you know water is polar. So just now you learn about solute and solvent. Polar can only mix with polar. Solvent, non-polar only can mix with non-polar. So water is polar, so we only look for polar, right? So this is non-polar. Non-polar mixed with polar most likely cannot apply. Okay, light dissolve light does not apply here because water is polar. Polar cannot mix with non-polar. Okay. Second material, CH3Cl. Again, start with 4-dimension analysis. Start with the type, whether it is ionic or covalent. So CH3Cl, no metal here. So it's a covalent molecule. Got polar or not? This one you need to draw the geometry lah. Then you see whether got lone pair or not. Usually got lone pair, then it is a polar. Okay, polarity, moderate, but it's a polar. If you draw the shape, right? So hydrogen bonding, got hydrogen or not? Yes, got hydrogen. But does it have FON? No. Okay, but means it accept hydrogen bond, but it do not donate, means it do not share the hydrogen. Solubility, because it's polar and polar, because water is polar. Polar can dissolve. So the answer is it able to dissolve. Maybe you cannot tell whether it is strong dissolve or weak dissolve, but it is dissolved because it's polar plus polar. solvent and solute. These two can form. Okay, so if you understand the first one, second one, you'll be able to do the NH3, which is the ammonia. Okay, ammonia, you look at type. It is a covalent, no metal there. Nitrogen and hydrogen is non-metal, it is covalent. Covalent normally is group number 4 in periodic table. Group 4 mixed with 5, 6, 7. 8 cannot, 8 is inert. Okay. So polarity, highly polarity. Because if you draw the shape NH3, it will be a T shape. T shape, you know, is polar already. Hydrogen bond, got hydrogen or not? Yes. Second step of hydrogen bond, check whether got F or N or not. Got N or not? Yes. So confirm got hydrogen bonding. Hydrogen bonding is the third strongest in intermolecular forces. The strongest is ionic dipole forces. Okay. So you have a strong donor and acceptor. Later in later chapter, later section, you will see which one is donor, which one is acceptor. Solubility in water, polar can mix with polar. We look at solvent and solute. It must be same type. Same type. KF, if you look at periodic table, one is metal, non-metal, it form ionic. So polarity is ionic. So ionic, it doesn't tell you whether it's positive or negative. It just form ion, right? It just form ion. So hydrogen bonding, does hydrogen or not? Don't have hydrogen. So no, do not have hydrogen bonding, right? So this one, hydrogen bonding, it just tell because it's ionic able to dissolve in water. It's like salt, NaCl. When you put NaCl inside ionic compound, you're able to break into positive negative charge. Solubility, very high, right? Very high. So this is how you do analyze, then give your conclusion. Ask you least soluble. Least soluble among these four will be number 1. Okay. So in final exam question, we'll ask you to arrange 4 elements based on the solubility from high to low or low to high. Then you need to give me the reason. So this is the way you write. You need to write in, sometimes the question mentioned cannot write in point form. You need to write in line. In line. So do not give me point form. Make this one in sentences. Make this one in sentences, but the keyword is there. Okay, so like this kind of question, how we give you marks? This one, if you give you 4 elements, this one at least will have 8 to 10 marks. So this one, if it's no, this one will be 8 marks. So this one will form each of these will give you 2 marks. 2 marks. Okay. But in test, because this one have 12 point, usually this one will give you 12 marks. Each point will give you 1 marks. Right? Right. So this is how you answer. So for the first section of this lecture, we talk about solubility, we talk about solute and solvent. And how we decide solubility is based on polarity. Polar solvent can dissolve in solute can dissolve in solute and solvent. Okay, non-polar and non-polar, polar and polar. Okay. Not all solid, however, dissolve in water. Okay. So now what we want to do now is we want to relate solubility solid in water to temperature. So we use this diagram. We'll use this diagram. Solvent interaction on the top, you see the blue dot. So this is solvent. On the top is solvent. On the bottom is solid attraction. Solute is minority component. Solvent is minority component. So these two able to dissolve when they are polar to polar or non-polar to non-polar. Okay. So if this solvent is polar, it must mix with polar. If the solvent is polar, it must mix with polar solute. When you say polar, means they got positive, negative side. Solvent, you have delta negative, will combine with positive ion. In this case, NaCl, ionic compound that become a solute, break into positive ion and negative ion. Positive ion will combine, will go to the negative side of the solvent. Cl will go to the positive side of the solvent. Right? So there are three types of attraction. Solvent to solvent attraction, which is on the solvent dimension. Solute to solute is on the solid dimension. Okay, one is solute, one is solvent. There's an interaction between solvent and solute, which is the red line. Okay. Okay, when you put a solid in water, you start to competition on the getting the negative charge, right? So attractive force in the solid is very, very strong, which is here. The two of this ionic bonding is very, very strong. Attractive force. Attractive force occurring between the water molecule and particles that compose the solid solvents, or this one is just tell you what is what lah. Basically explaining the attraction, three types of attraction. Yeah, able to understand this diagram? Yes. The important part is this diagram. You understand that three types of attraction. Solvent, solute, and solvent-solute attraction. The rest is just explanation in the text. Okay. All right. So the rest you read. This is might look complex, but you should able to tell how it's dissolved in water, sodium chloride with NaCl. So if you understand this diagram, there are three types of attraction: solvent, solute, and solvent solute. This diagram is actually a macro view, microstructure view, which is tell you what actually happened in the water in the molecular form. So here, if you look at this is the sum, what you see in the water and the salt. If you break into this one, left is a Cl. What happened to the Cl? On the right is what happened to the Na ion. Cl, you know that is negative, so it will orientate all the molecule water, the positive side, to the Cl. Because Cl is negative charge. So negative charge must arrange the compass, the direction positive to negative. So all the positive polar of the water will facing to the Cl negative side. Similarly to the Na. Na is positive ion. Positive ion attract negative side of the water. So the water negative side will orientate pointing to the Na. So this will be the interaction in the solution. Okay. The one on the left bottom and the right, this one is water and the ion, or if you refer back to the three definition, this is solute solvent interaction. Right hand side also solvent solute interaction, right? So the rest you read lah. I already explained the orientation of the positive side, negative side, and so on. Yeah? This one another, yeah, and one. Okay. So in NaCl, attraction to water is higher, so the sodium chloride dissolve. Right? Sodium chloride dissolve. This attraction to water wings, is compared to the NaCl, solid to solid attraction, is stronger than the water and the ion. It's more attractive for the ion to combine with the water. So the attraction of solute to solvent is higher, then it can dissolve. Okay, basically we are playing with these three attraction. Okay, if solvent attraction is strong, this one cannot break. Solute and solid attraction is strong, these two cannot break. So solvent solute attraction, if the red dot is stronger than the solute attraction and the solvent attraction, then it will dissolve. The red dot here, if the red dot stronger than the blue dot, it will dissolve. Can understand? Only three attraction here, and you just focus on the red dot and the blue dot. Okay, as long as which side is stronger, then it will stay in the state or it will dissolve. Huh? So in the case where the red dot stronger than the blue line or blue dot, then dissolve will happen. Huh? Both of them will dissolve. Huh? Okay. The rest you read. Huh? The rest you read. It's just explanation in text. Okay. So just now is we explained through using the three attraction force. Now we further define what is solubility and saturation. Okay. Solubility, we use mathematical equation. We define as the amount of compound, usually in gram, how many gram can dissolve in a certain amount of liquid. So this one is usually, we define the amount of solute that can be dissolved in solvent. Solubility, solubility means how many gram of solute can dissolve in solvent. Let's say we take salt. How many gram of salt can dissolve in water? It's called solubility. But when you come to exam, you need to use the technical word. You need to convert the salt and water as solvent and solute, or solute and solvent, right? So you need to use the technical word when you answer for exam. Yeah. So because you're looking for keyword. Solubility you define as gram in something. For example, sodium chloride in water at 25 degrees C is 36 gram per 100 gram of water. Meaning at 25 degrees C, if you have 100 gram of water, This is water, H2O. If you 100 gram of H2O, and you add, again, H2O is majority, so this is solvent, SO, 3 and solvent, right? So, and then you put in salt and ACl. This one is solute. You put in 36 gram into the water. It's called solubility of NaCl is 36 gram. What does it mean? If you add 37 gram, the extra 1 gram means the maximum water that can receive dissolved NaCl is 36 gram. If you give more, it also in the solvent, you can only see 36 gram contained in the water, inside the water. Meaning you'll see 1 gram, you see 1 gram at the bottom of this one. Here is 1 gram. Right? You see 1 gram at the bottom of the container. 36 gram of NaCl is inside the solid in the water. Okay, then you see 1 gram in the bottom. Okay, so solubility of calcium carbonate in water is close to 0. If you say solubility of calcium carbonate close to 0 means cannot dissolve. You put, let's say solubility is 0, calcium carbonate, CaC carbonate, CO something, CO3 something, right? So calcium carbonate is like your tooth, right? Your bone, right? You put inside water, you will see the bone or tooth at the bottom of the water, for example, right? Okay, solubility, again, you in the exam, will ask you how many gram can be dissolved in a certain solution. Right? So these are the phenomena that you see, right? See when you dissolve something. Okay, now we start to categorize your solubility of or condition of your solubility. First type is called unsaturated solution. Again, now what is solution? You take solvent plus solute, it forms solution, right? So unsaturated means you can add more space, add more solute inside the solution, inside the solvent. Unsaturated. Okay. Another category of solution is called saturated. Saturated means the maximum amount of solute can put inside the solvent. For example, the NaCl and the water just now. If you reach saturated solution, means you inside there you have 36 gram of NaCl in 100 gram of water. It's a condition where the perfect balance between solvent and solute. So you can see the illustration here. Illustration here. Super saturated means super saturated means the solvent is more than the amount of saturated already. Like for example, salt. You put in more than 36 gram inside the solvent. It becomes super saturated. So it represents by the orange dot. Okay. Then, if you add a seeding crystallize, means you add a extra solid that can form, that it can start the seeding, right? Then you will see precipitation. or precipitate means the one at you see in the bottom, it will form. If you have more than the supersaturated, then you add seed, you will see a phenomenon called the one that fall below the container is called precipitate or precipitation happen. So these are the 4 technical words in chapter 4. Okay. Normally the question will start from here. It asks you to determine how many mole of unsaturated this one. Then the question will continue to ask you by adding how many mole or how many gram of solute, it will form saturated solution. Then after that, after you calculate the amount of gram in the solvent, then you ask you by adding how many mole, what happened to the solution. So we expect you write supersaturated solution. Okay, so here you calculate how many mole, then you add solvent, add solute. You reach a state called saturated solution. Later we have calculation for this one. You get one magic number. How many grams of maximum solute it can dissolve? Then you keep adding. You need to explain the phenomena called supersaturated. By using supersaturated solution at crystal, phenomena you will see is precipitation will form, or precipitate will form. So it's a set of sequence that is expected lah. The answer is expected. You move from the left to right. Okay. Now, how to form unsaturated solution from saturated solution? How to form B to A? You add more solvent, add more water, for example. Okay. So you need to add solvent to go back to unsaturated. Okay. So if you move from the left to right, you add more solute. We still play with the 2 words, solute and solvent. Solute, solvent. These 2 things. Let's say I put solute is A, solvent is B. If you move from A to B to C to D, from left to right, you add more solute. If you want to reverse from D cannot lah. D already precipitate. You want to move from C to B to A, you add more solvent. How many you add later? There's a calculation there, but concept you understand first. I get a bigger picture first. Then we will go into calculation. Okay. All right. So the rest you just read lah. If you understand what I explained to you. Saturated solution hold the maximum amount of solute under the solution condition. This is definition. If the question asks you, what is saturated solution? Important for your test 1 or final exam. I forgot already. This one come out. I'll give you tips already. Okay, you need to give temperature. And maybe you need to draw a little bit. Okay, you draw a little bit. Okay. You don't need to draw the orange one, but you need to draw, like for example, what happened to the color and so on. And if you reach saturated solution, if you continue to add solute to it, the solute will not dissolve. Okay, the solute will not dissolve. Let's say I take NaCl, salt. If you already have 36 grams inside, you add in 37 grams, the extra gram will fall into the bottom of the container. Okay, it will not dissolve. Why? Because saturated solution definition is maximum, it hold the maximum amount of solute under the solution condition. Okay, condition here means condition here in chemistry, the concentration, the temperature of the solution, and so on. Okay. Okay. So if you understand, saturated means unsaturated means hold below the maximum amount. Okay. Saturated is maximum amount of solute. Unsaturated is less than maximum amount of solute. If you add in unsaturated solution, if you add solute, it will dissolve. So I forgot, either in test or final exam, you need to answer. If you given a certain amount of solute, will it dissolve or not? Why? Okay. The expected answer is you need to tell me whether it's in what condition. It is in unsaturated condition, saturated condition, or supersaturated condition. Okay. Right. Supersaturated hold more than the normal maximum amount. This is a definition. Supersaturated solution hold more than the normal maximum amount of solute. And you will see solute will normally precipitate from the supernatural solution. Okay, this is standard answer if it asks you about the solubility of the solution. These are standard answer. So it means if it's reached supersaturated, what happened? You need to explain what happened. Okay, how you know it's supersaturated? There's a calculation. After you get the magic number of the maximum amount, if that number is more than the numbers, then it will form supersaturated solution. Then you need to explain what happened if you keep adding more solute. The answer is the solute will normally precipitate from the supersaturated solution. Yeah? Any question so far? No, Okay. Right, so these are the photo that you will see in a normal daily life, right? So this is supersaturated. If you put in extra seeding element, it will form crystal, and the whole beaker will, whole container will become solid. Okay. Okay. Yeah. Right. We have done with type of solution. Now we need to prepare a solution called electrolyte solution, which is we dissolve ionic solid. Ionic solid means it can form ion with a positive and negative charge. For example, NaCl. Okay. Of course, NaCl you won't see in test or final exam anymore because it's too common and was mentioned in the test, in the normal class. So in the test, we will give you another ionic solid so that you have chance to answer. Okay. Right. A sugar solution and salt solution are very different. Okay. So as you can see here, if you compare salt and sugar, you already know NaCl will become electrolyte and it can conduct electricity. Sugar cannot. This is the normal, this one. So if it's able to conduct, or inside there got positive ion, negative ion, chemistry term is called electrolyte solution. Okay, electrolyte solution. So just now got 4 terms: unsaturated solution, saturated solution, supersaturated, and the one is after supersaturated, you have precipitate form. Don't confuse with electrolyte solution. Electrolyte solution only happen when you have ionic compound. Okay. Okay. Okay, so this is just an illustration, if you understand. Okay. Electrolyte can conduct electricity. Non-electrolyte cannot conduct electricity. How you test it is to a normal illustration of how you test it, whether it can conduct electricity or not. You connect with the wire and bulb. Then if you see the bulb light up, means it can conduct electricity. Okay. Okay, so this is the definition of what is electrolyte solution. It asks you the solution, the definition of electrolyte solution. So you need to mention a solute that the associate or can be break into ion is called electrolyte solution. So if you have a solute that can break into ions, then you can form electrolyte solution. Sugar is not electrolyte solution. So this just to recap what is ionic solid, what is non-ionic solid or covalent bonding solid. Okay. This is a chart of solubility in gram over 100 gram of water versus temperature. Let's say I pick one that you're familiar with is NaCl, the salt. Normal temperature, room temperature 20 something, will be about how many grams? 36, right? So it's about here. So if room temperature, let's say I pick 30 degrees C, you will cross a purple line here, will be about 35, 36 gram over 100 gram of water. If you increase temperature, you see the line will increase. If you go to 100 degrees C, you can dissolve 40 gram of salt. Yeah. So here it just tell you want to increase solubility, you give energy, you increase temperature. Yeah. Standard case is 25 degrees C. We call it standard condition, which is 25 degrees C, is the condition that we say for the solvent or solute. Okay. Okay. So this one also can become a question where we give you this graph and we ask you how many grams to form saturated solution. You know that saturated solution for NaCl is 36 gram, right? How you get 36 is from this graph, right? At 25 degrees C, so here, I move this from here, 25 degrees C. I move up, I touch NaCl. I move to the left, I get one number, about 35, 36 gram. If this one come up in test or final exam, of course, NaCl, I won't ask you anymore. It will be one of these elements that asks you how many gram that you should add to the solvent, for example, in water, to form saturated solution using this graph, right? So it will give you a temperature. If temperature is not given, assume 25 degrees C. So let's say the question asks you CaCl2. CaCl2, you see this curve, right? 25 degrees C, you move from the 25 degrees C here, you move up, you touch one point here, move to the left, you need to draw, not draw lah, you just need to tell me from the graph, 25 degrees C intersect with the orange color line, a red line, move to the left, you'll get about 85 lah, about 85 gram. In the exam will be plus minus 1% of this one. So 1 or 2%. So in this graph, if it's CaCl2 to form saturated solution, will be from this graph will be about 85 gram of CaCl2 at 25 degrees C. Okay. All right. The next question will be if I use CaCl2 again, and I give you 40 degrees C, what will be the amount of solubility to get the saturated solution? If the question asks you 40 degrees C, what is the amount of CaCl2 to form saturated solution? You cannot read. The answer can be the amount is undetermined from the graph given. Yeah. So in chemistry 2, some question don't have answer one. It cannot solve based on the data, or some question I give you a checklist or there's a table. Inside table there's no element. The answer is unsolvable because in the appendix the elements is missing. It can be the answer. Right? So don't leave it blank. Sometimes cannot find answer also the answer. Right? Right. The rest, if you understand, then should be fine lah. Right? For example, the first one, KNO3 at 20 degrees C, what is a solubility or how to form a saturated solution? You just based on the line and then based on the temperature. So all kind of question will be in temperature. So of course, chapter 4, you will see Celsius because the graph is in Celsius. Right. And so the rest I just show you how to get the answer and so on. Any question? All right. Yeah. All right. Okay. So solubility of some ionic solid in the function of temperature. So how you find it? So one is single solvent crystallization. Means you want to, okay, this is how to form a crystallization, how to form a crystal from ionic. Ionic compound can be ionic compound. One characteristic is you can form crystal shape solid, right? Or diamond shape solid. So if you have single solvent crystallization, this is the step lah. I won't ask you in a test or final exam. If I ask, I will let you know. Right? Okay. So how we do? You always start with the solvent, then you add solute, you mix, then mix until you maximize the number of solvent. It will form supersaturation. Okay. You see, supersaturation. You see the thermometer here. This one at the room temperature. How to form supersaturation? You increase the temperature. You add more. Increase. Then you form supersaturation. When you cool down, then precipitation happen or recrystallization happen. Okay. If you write precipitation, also correct. So this is how you get single step recrystallization. Huh? How you get recrystallization? Single step. You add the solvent, increase temperature, stir again, cool down, you will see precipitation. This is single steps. Okay, I think got one question ask you about this one. How to purify a solid? Through recrystallization. The answer that we expect is recrystallization. Okay. So maybe you need to explain a little bit. I think I recall I said a question in this one. I asked you how to purify something. So this is a step. Why this step can purify? This is how you purify. You recall back the solid. Yeah. So how you purify? Through recrystallization. How you conduct recrystallization process? The first step is single solvent recrystallization. This is single solvent, means you only have one type of solvent. One type solvent, one type of solute. 1:1. Second step, just now is single solvent. Second type, multi-solvent recrystallization. Multi-solvent means you add in more than one type of solvent. For example, you start with a solvent, room temperature, you add in solute, you stir, you increase temperature again, you add in solvent, it becomes supersaturation. Then between the cool down, before you cool down, you add in anti-solvent. You stir, it becomes two solvent already, because solvent number one is the blue, sky blue color. You add in green color, another solvent, it will become new solvent. Then you cool down, it will recrystallization. This is another method of purifying a solvent. Okay. Multi-solvent usually goes for solid complex molecule that you add anti-solvent to remove one of the component. Right? Okay. So again, the most simplest one is single solvent, which is add, increase temperature, cool down. Multi-solvent, you add anti-solvent in one of the process before cooling down. Hot filtration. Hot filtration. What is the difference? Is the word filtration. Hot means you do it in the high temperature. Start with solvent, add solute, increase temperature, mix, right? Stir it, reach supersaturated. You pour in the filtration, you use a filter. You pour. Then this one happened in a high temperature. In high temperature, in the real experiment, there is a inductor, induction thermal instrument that warm the solution. Right? All these are in high temperature. Then you do filtration, then you cool it down. Okay, this is hot filtration. Okay. Initially, I plan to do this activity with you. With this, we will create rock candy in one of the lab sessions. I think no need lah. But because it takes almost 4 weeks, 4 weeks to see this crystallize to form. Take a lot of time lah. But if you want to do this one during your free time, go ahead lah. Okay. So how to do? It's very easy. You form supersaturated solution. You pour in sugar, then you mix. You heat it up, you pour in the jar, Then you use bamboo sticks. You dip with bamboo stick with water. Then you dip inside the sugar, coat the bamboo with sugar. So this one is like to start the crystallization. Then you dip the chopstick with the sugar into the supersaturated solution. You leave it over time. Then new crystal will form. Then at the end, you will see something like this. The colors actually is the fruit coloring lah. Okay. It's quite interesting experiment, but it take too long to get the results. So this one usually for kids lah, right? For kids. Right. So I show you the video. Sorry for the advertisement. Okay. So this video is from Size Guy. Is for seeding. So this will form a supersaturated solution. So this one take about 3 to 4 weeks to form this one. So you'll grow crystal. Right? Yeah. This one is fast forward video. So, yeah. So the top will solidify. What is important is what along the bamboo stick. So again, this is like a syrup already. It's a candy lah. Basically, it's a candy sticks. Right, so this one can be done during the science camp, 3 days or 4 days of camp, and usually we will conduct this experiment. Okay, so basically this use the concept of the solution, supersaturated solubility, and so on. Yeah. Okay, the rest if you interested, you can. Oh. Okay, the next one is we have done with the liquid. Now we go into gases in liquid. I think 2 more slides, then we call it a day. Okay. The first one, already done with the liquid. Now we go into how gas dissolve in liquid. We will change the pressure. Just now, if it's liquid and solid, we change the temperature. Now, if it's gas and liquid, we use pressure. Okay, we use pressure. So the higher the pressure above the liquid, the more solubility of gas in the liquid. You higher the pressure, higher the solubility in the liquid, gas and liquid, right? So the illustration here is the molecule gas, and you increase the gas pressure, then more solubilities. Here we want to highlight is called Henry's law. In one of the test question or final exam question, it will ask you to define what is a certain law, right? Okay, so if it asks you about solubility and pressure, you need to bring out Henry's law, right? Henry's law mentioned higher the pressure above the liquid, you need to mention above the liquid. Higher the pressure above the liquid, the more soluble the gas is in the liquid. Henry's law linked with solubility of gas and liquid. Gas in liquid. Deal with Henry's law. Don't confuse with Boyle's law and Charles' law. Boyle's law, Charles' law are gas. Chapter gas. Now in chapter 4, right? Liquid and solid. Now deal with gases in water. Okay, this is just information. Important is this. Henry's laws is solubility proportional to pressure. Whereas you just remember C equal to Kp. We will revisit this equation later when we talk about concentration. But at the moment, you just accept Henry's law equation is C equal to Kp. Concentration of a dissolved gas equal to constant, Henry constant, K, multiplied by the partial pressure of the gas. We have studied what is partial pressure. Okay. So remember C equal to Kp, and then you explain what is the parameter that you use. Since this is constant, so you can mention concentration of the dissolved gas is proportional to the pressure. Okay. So this is just illustration. The more pressure, the more gas is dissolved. Okay, again, Henry's law, C equal to Kp. Application is in especially those divers. The deeper you go, the more gases are dissolved in your blood. Okay, so this just to do lah. Okay, so this phenomena in soda pop, the pressure is provided by large amount of carbon dioxide gas that is pumped into the gas before seal it. So this is Coca-Cola. Why soda drink can have bubbles? It is because of the pressurized condition. All right, so it can happen. You can see bubble in any pressurized liquid. You open it, it will have formed bubbles. This phenomena is explained by Henry's law. Okay, this is things lah. in beer, in Coca-Cola, or any gas pressurized drink. Okay, so this one you read, this one you read. Okay, give me 2 more minutes, then we stop. Okay. Okay, we have done with solubility. Now we go into one more with concentration. We start with concentration and then we stop. Now, concentration we define by mass percent. Okay. So dilute solution is have small amount of solute. Concentrated solution is containing large amount of solute. Right? But here is just a statement, but how do you quantify? How do you say a certain percentage is dilute, a certain percentage concentrated, right? So in daily life, how you know is dilute and concentrate by observation. Normally we observe by color. Darker the color means it can be concentrated, more concentrated solution. You look by color, right? Okay, mass percentage. This is the equation before we stop. Mass percentage, how we calculate? We take the mass solute, divide by the total mass. Divide by the total mass of solvent plus solute. Multiply by 100%. For example, we take 36 grams and 100 grams of water just now to form saturated solution of water and NaCl. If you use this solution, what is the mass percentage of saturated solution for salt, NaCl, and water? So basically, if you use salt and water example, to form saturated, you take mass percentage equal mass of solute in this case is 36 grams of NaCl. Below is 36 grams NaCl plus 100 grams of H2O. You press calculator, 36 divided by 136 multiplied by 100%. I don't know. You press calculator. You'll be in percentage. How many percent? 100%. 100%. 36 divided by 136. How many? I multiply 100. How many? Huh? 36.47. Okay. So this in mass percent will form saturated solution. If you use solute, NaCl as your solute, water as your solvent. Okay. If you understand, then it should be done. This one is another example. So if you understand this equation, you should be able to understand this example. You are given 15.3 grams of NaCl solute and mixed with 155 per gram of water, you should be able to find mass percentage. So if I show you the answer, you should be able to understand. So this is the mass percentage of this combination. Okay. So you need this one in your lab report. You're given a certain solute, you mix, you stir, then you find mass percent of that solution. Yeah. So now if you talk about concentration of something, you need to tell me what is the percentage of mass percent. This is a mass. Later we convert mass into mole. The first type of concentration, mass percent. Okay. So your answer for a certain type of concentration, for example, this tutorial question, the solution is 8.98% NaCl by mass. If you calculate using mass percent equation. In test or exam, please write a short statement of your conclusion. Please write a short sentence of your conclusion. Don't stop at your calculation like that. Don't stop at equation. For example, don't stop at 8.98%. You need to write a short sentence. What is your solution? Okay, I think we are done. Second example, you should able to do. If you're given, ask you to find mass percentage of solution contain 27 gram of ethanol, and give you the equation, and 175 ml of H2O. Assume you're given density, you should able to convert density and volume into gram. No, not. How to find mass using volume? Density multiply volume to get mass. Okay. So again, the way of solving question in chemistry 2, you need to write the general equation, 1 mark for the general equation. Step substitute with the unit, 1 mark. Final answer will be 1 mark to 2 marks. So this whole set costs you 4 marks. Okay. This one, another one, you should be able to do. Okay, we stop here. Yeah. Okay, we stop at this tutorial question. We'll continue next lecture. We stop at 4.5.